NEC Section 310.15b7 requires a 6 AWGTHHN conductor for a 45 amp circuit. NEC Section 310.16 states a neutral is not required for a load that does not require it. Consider a situation involving a 6 AWG feeder to a 4-circuit subpanel where each circuit supplies a 240 volts load, and there are no 120 volts loads in the subpanel. Based on the NEC requirements, a neutral conductor is not required for this application. The 6 AWG feeder is sufficient to carry the 45 amp load, and there is no need to provide a neutral since the loads do not require it. The authority having jurisdiction, or ODJ, may have misinterpreted the NEC requirements or may have been following a local code that has stricter requirements than the NEC. In such cases, it is important to review both the NEC and local codes to ensure compliance with all applicable requirements. Contacting the AHJ and explaining the reasoning based on the NEC and any relevant local codes is also important. Providing documentation such as a load calculation or electrical diagram can help support the claim that the feeder is adequately sized and that a neutral is not necessary. Let's delve deeper into the NEC requirements and explore the nuances of feeder sizing and neutral conductor requirements. The NEC, or National Electrical Code, is a widely adopted standard for safe electrical installations. It provides guidelines for various aspects of electrical systems, including conductor sizing, overcurrent protection, grounding, and wiring methods. Understanding the relevant NEC sections is crucial for ensuring compliance and avoiding potential hazards. When sizing a feeder, it is essential to consider the load it will serve. The load is the total amount of electrical power that the feeder will supply to the connected equipment or devices. The NEC provides specific guidelines for calculating the load based on the type of equipment and its power consumption. Once the load is determined, the appropriate conductor size can be selected based on the ampacity of the conductor. Ampacity is the maximum amount of current, measured in amps, that a conductor can safely carry without overheating. The NEC provides ampacity tables that list the ampacity of different conductor sizes based on their material, insulation type, and installation conditions. In the example scenario, the 6 AWGTHHN conductor has an ampacity of at least 45 amps, which is sufficient for the 45 amp circuit. However, it is important to verify the ampacity based on the specific installation conditions, such as the ambient temperature and the number of conductors in a raceway or cable. The NEC also addresses the need for a neutral conductor in a feeder. A neutral conductor is a grounded conductor that provides a return path for current in a single-phase or three-phase electrical system. In a 240 volts only system, where there are no 120 volts loads, a neutral conductor is not typically required. This is because the 240 volts loads are connected between two ungrounded conductors, and the current flows directly between them without the need for a neutral return path. However, there are some exceptions to this rule. For example, if the 240 volts loads are sensitive to voltage imbalances or harmonics, a neutral conductor may be required to provide a stable and balanced voltage supply. Additionally, some equipment may require a neutral conductor for control or signaling purposes, even if it does not directly use the neutral for power. It is important to consult the equipment manufacturer's instructions and the NEC to determine if a neutral conductor is required in such cases. When dealing with an AHJ inspection failure, it is crucial to understand the reasons behind the failure and to address them in a professional and respectful manner. The AHJ is responsible for enforcing the electrical code and ensuring the safety of electrical installations. They may have different interpretations of the code or may be following local amendments that are stricter than the NEC. Firstly, review the NEC and local codes to ensure that the installation complies with all applicable requirements. Pay close attention to the sections related to feeder sizing, neutral conductor requirements, and any other relevant aspects of the installation. Secondly, contact the AHJ and explain the reasoning behind the installation design. Provide clear and concise explanations, and be prepared to answer any questions they may have. It is helpful to have supporting documentation such as load calculations, electrical diagrams, and equipment specifications. Thirdly, if the AHA still disagrees with the installation, respectfully ask for clarification on their interpretation of the code. Try to understand their concerns and address them to the best of your ability. If necessary, seek assistance from a qualified electrical engineer or consultant who can provide an independent assessment of the installation. Furthermore, consider the potential for future expansion or changes in the electrical system. While the current installation may not require a neutral conductor, it is possible that future loads or equipment may require one. In such cases, it may be prudent to install a neutral conductor now to avoid the need for future modifications. The cost of installing a neutral conductor during the initial installation is typically much lower than the cost of adding one later. Additionally, ensure that the subpanel is properly grounded. Grounding is a critical safety feature that provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock hazards. The NEC requires that all metal enclosures, including subpanels, be grounded. The grounding conductor should be sized according to the NEC guidelines and should be connected to a grounding electrode system such as a ground rod or a metal water pipe. Moreover, consider the use of surge protection devices, or SPDs. SPD are designed to protect electrical equipment from voltage surges caused by lightning, power outages, or other transient events. Surges can damage or destroy sensitive electronic equipment such as air conditioners, appliances, and computers. SPD are typically installed at the main electrical panel or at subpanels to protect the entire electrical system. They work by diverting the surge current to ground, preventing it from reaching the protected equipment. When selecting SPD, it is important to consider the surge current rating, the voltage protection level, and the type of SPD. The surge current rating indicates the maximum amount of surge current that the SPD can safely handle. The voltage protection level indicates the maximum voltage that the SPD will allow to pass through to the protected equipment. There are two main types of SPD. Type 1 SPD are installed at the service entrance, and Type 2 SPD are installed at subpanels. In addition to the technical aspects of feeder sizing and neutral conductor requirements, it is also important to consider the aesthetic aspects of the installation. Ensure that the wiring is neat and organized, and that all connections are properly made and tightened. Use appropriate cable ties or clamps to secure the wiring and prevent it from becoming loose or damaged. Label all circuits and equipment clearly and accurately. This will make it easier to identify and troubleshoot any problems in the future. Furthermore, consider the environmental conditions in which the electrical system will be operating. If the system is exposed to moisture, dust, or corrosive substances, it is important to use appropriate enclosures and wiring methods to protect the equipment from damage. For example, in damp or wet locations, use weatherproof enclosures and conductors that are rated for wet locations. In corrosive environments, use corrosion-resistant materials, such as stainless steel or PVC. Moreover, it is important to follow all safety precautions when working with electrical equipment. Always disconnect the power before working on any electrical components. Use appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. Never work on electrical equipment when you are tired or distracted. If you are not comfortable working with electrical equipment, hire a qualified electrician to do the work for you. In conclusion, understanding the NEC requirements for feeder sizing and neutral conductor requirements is crucial for ensuring the safety and reliability of electrical installations. When dealing with 240 volts only subpanels, a neutral conductor is not typically required, but there are some exceptions. It is important to review the NEC and local codes, contact the AHA, and provide documentation to support the installation design. Consider the potential for future expansion, the use of surge protection devices, and the environmental conditions in which the system will be operating. Above all, follow all safety precautions when working with electrical equipment. By following these guidelines, you can ensure that your electrical installations are safe, compliant, and reliable. Always consult the latest edition of the NEC and local codes for the most up-to-date information and requirements. The electrical industry is constantly evolving, and new technologies and standards are being developed all the time. It is important to stay informed about the latest developments and to adapt your practices accordingly. This commitment to continuous learning and improvement will help you to provide the best possible service to your clients and to ensure the safety of electrical installations.